In this video, I'd like to talk about the weapons used to fight energy vampires, both regulatory and technological. As a reminder, energy vampires consist of devices that consume power even when they're not doing their active function. Fortunately, we have a number of weapons at our disposal. From the regulation side, back in 1999, the International Energy Agency started the 1 watt initiative, which basically said, here's a goal, don't exceed 1 watt in terms of standby power. Since then, the keystone regulation is the horizontal standby regulation from Europe. And this regulation has been amended in 2013 to require that all energy-using products not exceed ½ a watt in standby. In addition, for networked products, they give an extra allowance because with connectivity, there's increased power expected. And that is about 2 watts nowadays in terms of the requirement for network devices. In California, there's a similar development going on with regulations to cover standby, and it is part of the low power mode roadmap. In this roadmap, they're taking a slightly different approach from Europe. They're using what they call a clustered horizontal approach. In the clustered approach, there's a grouping of these very disparate products into similar categories. So for example, you may have vampires related to small kitchen appliances, or you may have smart home vampires, such as a smart speaker with a connected thermostat. And so by grouping these together, there's certain commonalities that can be easier to regulate. On top of these categories, there may be common features that cross-cut the various groupings. So for example, there may be a small LED display. That could be for a kitchen appliance or a smart home product. Or voice recognition could be an additional feature for, say, a smart speaker or even a kitchen appliance. So by slicing it this way, it is a more precise way to carve out the landscape of products for easier testing as far as the regulation goes. Now, beyond the regulatory weapons, we also have quite an arsenal of technological weapons. These include power device technologies such as gallium nitride or silicon carbide, where efficiency is boosted in general for all power conversion. Now, more specific to controlling standby, we have innovative control technologies that allow us to optimize the power delivery based on the loading. So for example, using on-off control, we turn off switching as the load decreases. Similarly, there is also CCM/quasi-resonant DCM hybrid control using optimized synchronous rectification to ensure that there is high efficiency across a wide load range. Finally, when it comes to sensing the input for undervoltage or overvoltage protection, there are lossless approaches that we can use on our chips to avoid the need to have resistors that dissipate power wastefully. So all of these are great ways to incorporate these technologies to reduce standby without us having to walk around the house and unplug all of those 65 devices. In summary, these regulatory approaches and technological weapons have been very effective. In fact, the European horizontal standby regulation by itself has saved 35.5 terawatt hours per year. That's equivalent to the annual energy consumption for the entire country of Romania. So Dracula himself would be proud. Beyond that, we can also look for more improvements as the European Commission considers dropping the threshold from ½ a watt down to 0.3 watts or even 0.2 watts. For more information on energy efficiency regulations and activities, feel free to check out power.com/greenroom, where you can also find Mr. Green's blog. Thank you so much for listening.